So this is John's question. Of course, he only asked about part B, but we can quickly look at question part A using the calculator method, because we use the triangle method in the other two questions. So to solve this equation, you can simply use this identity. This is equal to cos A cos B minus sin A sin B. So I can just expand the left hand side. So on our left hand side we have cos theta plus 30 is equal to sin theta. So I can just expand the left hand side using this identity. So this will be cos theta cos 30 plus, actually this would be minus sin theta sin 30, which is equal to sin theta. And then we can just punch cos 30 and sin 30 on our calculators. So cos 30, this is well known. This is like the square root of it's actually the square root of 3 over 2, which is approximately 0.8660 and some numbers. And then cos theta. So it's better to write this as a coefficient, not putting it this side. And then sin 30, this one is well known as well. This is 0.5 sin theta, which is equal to sin theta. Then if I take this one to the other side, by the way, this is my 5. It looks a bit like an 8. I mean like an S. So I can take the sin theta to the other side and add it to this. So this one will be 0.5 sin theta plus sin theta. And then we have 0.866 cos theta. Then when you add these two, you have 1.5 sin theta. So at this stage, you want to introduce the tan. But remember that tan theta is defined as sin theta over cos theta. So to get this from this, you can simply divide both sides by cos. So once I divide both sides by cos, then this cos will go. Then we shall remain with 0.866 on our left hand side. Then this side we have 1.5. This is tan theta. And then you can simply divide both sides by 1.5 to remain with tan alone. Then I can write it this side. So this and that will go, and then 0.6 divided by 5 using my calculator, this is 0.5774, like this. And then to find theta, I can simply start by finding my alpha. Since tan is positive, it means theta is in the first quadrant. Remember, all angles are positive in the first quadrant. And then tan is also positive in the third quadrant. So I'll need these two. And in the first quadrant, theta is equal to alpha. Then in the third quadrant, theta is equal to alpha plus 180. So let's find alpha first. So you can say tan alpha is equal to the modulus of 0.774. And then our alpha will be tan inverse of that. This is giving me 30. 30 degrees. So this is our alpha. So in the first quadrant, theta is equal to 30. And then in the third quadrant, theta is equal to 30 plus 180. So if there was a lot of rounding off at any of these stages, then you expect to get something like 29.99 and some numbers, which will still round off to this. So that's acceptable too. So this would be 210. So this solves the first part of the question. To solve the second part, we shall expand this using the identity sin A plus B is equal to sin A cos B plus cos A sin B. So in the question, we have been told that cos A is 3 over 5. So cos A, this is cos A, this is 3 over 5. And cos B is negative 3 over 13. So this part is negative 3 over 13. Where angles A, the angle A is acute, meaning that it's between 0 and 90 degrees. And angle B is obtuse, meaning that it is somewhere between 90 and 180 degrees. So now, to find sin A or cos B, or sin A, sin B rather, you can either draw a triangle for this one and obtain the other angle, like the sin A, but I think this may be a bit challenging using the triangle method to do this. So I think the easiest way to find the corresponding sign ratios for A and B is to use the identity sin squared A plus cos squared A is equal to 1. And then since we already know what cos squared A is, remember it's 3 over 5, we can simply say 3 over 5 and then the square there is equal to 1, and then we can solve for A. So for sin A. So you can just take this one to the other side. You have this, and then minus, when you square the 3, you have a 9, you square the 5, you have a 25, and then when you subtract, this will be, this times this, 25 minus this is 16 over 25. And then since you want to find the sin A, not sin squared, you can simply introduce the square root on both sides. And then in the statement here, we've been told that angle A is acute. So if A is acute, then it's somewhere between 0 and 90 degrees. So that means you expect all the angles to be positive in this range. So you don't need to put plus or minus there. You just get the positive value of the square root. So the square root of 16 is 4. The square root of 25 is 5. So this is our sin A. You don't need to find A. You just want the sin A like this, because you want to substitute this part with the value of sin A. So you can do the same thing to find the value of B. So the identity is sin B squared plus cos squared B is equal to 1. And then our cos B is known. This is negative 3 over 13. So sin squared B plus negative 3 over 13 squared. This is equal to 1. Then when you square the negative 3, you have a 9. Okay, let me just take them to the other side. You have 1 minus, you square the 3, you have a 9. You square the 13, you have 169. And then when you subtract these two, you should have 160, I think. Let me just, so this times this is 169 minus 9. This will be 160, yes? One 160 over 169. Yeah, so now to solve for b, for sine b, you simply introduce the square root on both sides. Unfortunately, the numerator has no square root, and I don't want to introduce radicals or thirds, so I'll just leave it like this, or maybe punch it on the calculator to get the estimated value of this. So if I punch this thing on the calculator, the square root of 160 divided by 13, this will give me 0.973000851 as our sine b. So now all you have to do is substitute each of these in there. And by the way, I took it as a positive number because I know that b is obtuse, so that means it is in the second quadrant where sine is positive. So now I've written them all down. This is our sine A, cos A, sine B, and cos B. So all you need to do now is to substitute each of these in the expansion there. Sorry, this is sine A plus B. So our sine A is 4 over 5. And then our cos B is negative 13 over, negative 3 over 13. And then plus cos A is 3 over 5. And then sine B is 0.973, like this. And then you can simply add these two numbers and multiply, then you are done. So I'll just punch everything on the calculator. So 4 divided by 5, I think this is known. This is 0.8, I think. 4 divided by 5, yeah, that's 0.8. And then we have negative 3 over 13. And then this is 0.6 multiplied by 0.973. And then I can just multiply these using my calculator. You can say 0.8 multiplied by 3. This is 2.4 divided by 13. We have 0.1846 plus 0.6 multiplied by 0.973. This is 0.5838. Then we can add these two numbers. So we have 0.1846 plus 0.5838. Of course, this one is negative, so we are actually subtracting And this is giving us 0.3992, which is approximately 0.399, and you are done.